Model evaluation in AI. Model evaluation in AI. Beginner level. Introduction. Artificial intelligence. AI and machine learning models are built to make predictions or decisions based on data. However, after training a model, it is important to determine how well the model performs. This process is called model evaluation. Model evaluation helps determine whether a machine learning model is accurate, reliable, capable of making correct predictions on new data. Without evaluation, it would be impossible to know whether the AI model is useful or needs improvement. Understanding model evaluation is an important step in learning machine learning and artificial intelligence. What is model evaluation? Model evaluation is the process of measuring how well a machine learning model performs using specific metrics and testing data. In simple words, model evaluation equals checking how accurate and reliable the AI model is. Example concept. Trained model means testing data means performance measurement. Evaluation helps developers understand how well the model generalizes to new data. Why model evaluation is important? Model evaluation helps solve several important problems. Measure accuracy. Evaluation metrics help determine how correct the model's predictions are. Detect overfitting or underfitting. If a model performs well on training data but poorly on testing data, it may be overfitting. Example concept. High training accuracy means low testing accuracy. Improve model performance. Evaluation results help developers adjust and improve models. Compare different models. Developers can compare multiple algorithms and choose the best performing model. Training data versus testing data. Model evaluation requires separating datasets into training and testing data. Example concept. Dataset means training data means model training. Means testing data means model evaluation. The model is trained using one portion of the data and evaluated using another portion. Common evaluation metrics. Different machine learning tasks use different evaluation metrics. Accuracy. Accuracy measures the percentage of correct predictions made by the model. Example. Accuracy equals correct predictions, total predictions. Example. If a model correctly predicts 90 out of 100 cases, the accuracy is 90%. Accuracy is commonly used in classification problems. Precision. Precision measures how many predicted positive results are actually correct. Example concept. Precision equals true positives, predicted positives. Precision is important in problems where false positives are costly. Example. Fraud detection systems. Recall. Recall measures how many actual positive cases were correctly detected. Example concept. Recall equals true positives, actual positives. Recall is important in applications like medical diagnosis. F1 score. The F1 score balances precision and recall. Example concept. F1 score means balance between precision and recall. This metric is often used when both false positives and false negatives matter. Mean squared error. Regression. For regression problems, a common evaluation metric is mean squared error. MSE. Example concept. MSE equals average of squared prediction errors. Lower MSE indicates better model performance. Confusion matrix. A confusion matrix shows how many predictions are correct and incorrect. Example. Actual, predicted positive negative. Positive true positive false negative. Negative false positive true negative. Example concept. Prediction results means confusion matrix means model analysis. Confusion matrices help understand where the model makes mistakes. Example Python code. Example model evaluation using Python. From sklearn. Metrics import accuracy _score. Machine learning libraries such as scikit-learn provide many tools for evaluating models. Machine learning evaluation workflow. Typical evaluation workflow. Dataset means model training means model testing means evaluation metrics. This workflow ensures the model performs well before deployment. Real-world applications. Model evaluation is critical in many AI systems. Healthcare AI. Evaluating diagnostic models to ensure medical accuracy. Fraud detection. Testing models that detect suspicious financial transactions. Recommendation systems. Evaluating how well systems suggest products or movies. Autonomous vehicles. Testing AI models that interpret road environments. Concepts learned from model evaluation. Understanding model evaluation helps beginners learn. Checkmark how machine learning models are assessed. Checkmark how to measure prediction accuracy. Checkmark how to improve model performance. Model evaluation is a fundamental step in machine learning pipelines. Simple definition. Model evaluation. The process of measuring how well a trained machine learning model performs using testing data and performance metrics. Final summary. Model evaluation is an essential step in artificial intelligence and machine learning. After training a model, developers evaluate its performance using testing data and evaluation metrics such as accuracy, precision, recall, F1 score, and mean squared error. These metrics help determine whether the model is reliable and capable of making accurate predictions. Model evaluation also helps detect overfitting, compare algorithms, and improve AI systems. Understanding model evaluation is crucial for building accurate, reliable, and effective machine learning models.